In this lesson, we're going to look at how to add and subtract rational expressions that have the same denominator. So first we're going to combine the tops. Then we're going to pick out what numbers would make the denominator equal 0, because those numbers have to be left out of the domain. And then we're going to reduce if possible. So it's very much like adding regular fractions, except we have variable terms involved. Let's look at 5x plus 1 over x squared minus 9 minus 4x minus 2 over x squared minus 9. So just like when you did regular fractions, we need to subtract the numerators and leave the denominator the same. So let's write it like this. Here's my new top. 5x plus 1 here minus 4x minus 2, but notice I have it in parentheses because I have to make sure that I'm subtracting the entire second numerator. And then the denominator is x squared minus 9. So I'm going to do two things in this next step. First, I'm going to distribute the negative, but at the same time I'm going to factor the denominator. So negative 4x here, and then minus negative 2 makes plus 2 here. And then the denominator, when we factor it, is x plus 3 times x minus 3. Now since we've got the denominator factored, let's go ahead and pick out what would make the denominator equal 0. If x plus 3, well, since x plus 3 cannot equal 0, x cannot equal negative 3. And since x minus 3 cannot equal 0, x cannot equal 3. So these are the numbers we're going to leave out of the domain. And now let's continue with our combining the like terms in the top here. 5x minus 4x is 1x. And 1 plus 2 is 3, of course. And then the denominator, x plus 3 times x minus 3. And the x plus 3's will cancel, and we'll be left with 1 over x minus 3. And don't forget to note the numbers that have to be left out of the domain. So let's try another one here. So we have x squared minus 2x over x squared plus 3x plus x squared plus 1 over x squared plus 3x. And of course we still have the same denominator here. This time we have a plus sign. So when we combine the numerators, there are no parentheses necessary because we're adding, and the denominator will stay the same. Now let's go ahead and combine our like terms in the top. I have 1x squared plus 1x squared, and that makes 2x squared minus 2x plus 1. And the denominator is x squared plus 3x. Of course, it needs to be factored. So we have a GCF of x here. Let's factor out the x, and that will leave x plus 3 in the parentheses. Now, we need to figure out if this top will factor, because it is a trinomial, and it kind of looks like it might, but if you start working on it, you'll see that you can't get the middle term to come out right. So, the top will not factor, and that means we won't have any reducing to do here. But we do need to specify that the denominator cannot be 0, so that means x cannot be 0, and x plus 3 cannot be 0, therefore x cannot equal negative 3. Alright, let's go ahead and look at a subtraction problem. Let's do x over x plus 1 minus 3x plus 2 over x plus 1. So I'm going to be combining these numerators, but we have this same situation where we have a minus. We have to make sure and put this whole second numerator in parentheses to make sure the whole thing gets subtracted. And then I've got my same denominator of x plus 1. And let's go ahead and distribute that minus sign. So I've got minus 3x and minus 2. be careful here because that's a very common source of errors. People forget to distribute the minus sign all the way through. And then on the bottom, x plus 1. So if we combine our like terms in the top, we've got x minus 3x is negative 2x minus 2, and it's all over x plus 1. Now I'm going to pause here and let's figure out what makes the denominator equal 0. Since x plus 1 cannot equal 0, we know that x cannot equal negative 1. And now let's go ahead and factor this top, because I do see a GCF here of negative 2. So if I factor out the negative 2, then negative 2 times x makes negative 2x, and negative 2 times positive 1 makes minus 2. And let's go ahead and cross out the x plus 1's. And so this whole expression simplifies down to simply negative 2, but we cannot allow x to equal negative 1. And that's it for that one. So now we're going to start to look at how to add and subtract rational expressions that have different denominators. So just like when we add any fractions, we must get the denominators the same before we start adding and subtracting. And in order to get the denominators the same, we're going to need what's called a least common denominator, the smallest common denominator we can find. So here's how you do that. You're going to factor each denominator, and then you're going to list all the factors from the first denominator, and then you're going to add any factors from the second denominator that you didn't already put in the common denominator. And we're going to practice this process over the next few examples, so even if it doesn't sink in right now, it will before we finish. So here is our first example. Let's add x plus 3 over x squared plus x minus 2 plus 2 over x squared minus 1. And I have a trinomial here and a binomial here. So in order to see how to make my common denominator, I have to factor these first. The trinomial will factor into two binomials. First times first is x times x. The signs need to be different. And last times last needs to be 2 times 1. The 2 needs to go here so that outer plus inner can be positive 1x. For my second fraction, I have x squared minus 1, so that's a difference of squares, and the factoring will be x plus 1 times x minus 1. Now we're going to build our common denominator. It's really a pretty simple process. Copy down your first denominator, just like it is. Then look at your next denominator and see what factors you don't already have. So if I look at x plus 1, I do not already have an x plus 1 here, so I'm going to put an x plus 1 down now. If I look at x minus 1, I do have an x minus 1 here, so I'm not going to put down another one. So these three factors make up my common denominator. Now I'm going to recopy all of this so that I can work on it without messing up my original. You probably don't want to recopy, you probably just want to add to what you already have. Okay, now my goal is to make this denominator look like this, and then to make this denominator look like this. So I look at x plus 2 times x minus 1. What is missing? The x plus 1 is missing. So I can put an x plus 1 here, but I'll have to put 1 in the top as well. Look at this denominator. I have 2 of the factors already, but I am missing the x plus 2. So let's put the x plus 2 in there, but I'll have to put it if I put it in the bottom to make the denominators the same, I have to put it in the top as well. Okay, now here is the kind of drag part of these problems. We're going to end up actually doing this multiplication and this distributing because there's no other way to combine the like terms in the tops if we don't go ahead and do the multiplication. However, before we start, let's go ahead and figure out what's going to be left out of the domain. If you look at our first factor, x plus 2 cannot equal 0. That means x can't be negative 2. X minus 1 cannot be 0. That means x cannot be positive 1. And x plus 1 can't be 0. That means x cannot equal negative 1. So here we found the three numbers that need to be left out of the domain. Let's go ahead and multiply these two binomials together. So x times x is x squared, outer plus inner is 4x, and last times last is 3. Now I'm going to distribute this 2. And so here is our new numerator. And our denominator is still these three factors here. And of course it doesn't matter what order you write them in. Now this top has lots of like terms that need to be combined. So let's keep our x squared. 4x plus 2x is 6x. And 3 plus 4 is 7. And then the denominator is the same three factors we found for our common denominator. And you should look at your top number, top expression, and see if it can be factored. Of course, this one cannot. So there's nothing we can reduce here. We just need to make a note that those three numbers have to be left out of the domain. And so that's it. I know this is a little bit of a complicated process, but I think if you'll keep in mind how you handle regular fractions, I think it does help. You have to build a common denominator. You have to make each fraction have the common denominator. Then you have to multiply the tops out so that you can combine the like terms. And then you're pretty much done. So let's go ahead and look at a new example together. So here is a subtraction problem. X plus 2 over 2x minus 3 minus 4 over x plus 3. So I have two different denominators here. I need to make them the same, but at least there's no factoring to do here. So when I make my common denominator, the only factor of this denominator is 2x minus 3, and the only factor of this denominator is x plus 3. So those two factors together make the common denominator. Alright, now it's our goal to make both of these denominators look like this. So I'm going to copy the same problem again, and I look at this first denominator and I say this one needs an x plus 3. So I put x plus 3 in the top and the bottom. And then I look at this denominator and I say this one needs a 2x minus 3. So I put that denominator in the top and in the bottom. And now I'm going to go ahead and figure out what numbers have to be left out of the domain. Since 2x minus 3 is part of our common denominator, 2x minus 3 cannot equal 0. That means 2x cannot equal 3. That means x cannot equal 3 over 2. And the same thing for x plus 3. X plus 3 can't equal 0, therefore x can't equal negative 3. Okay, now, this is the only little kind of draggy part of these problems, is that in order to get the tops combined, we actually do have to carry out this multiplication, and we have to distribute negative 4 here. So let's go ahead and do the FOIL method on these two binomials. First times first is x squared. Outer plus inner will be 3x plus 2x, that's 5x. And last times last will be 3 times 2, that's 6. Now for the second one, I have to distribute negative 4. Negative 4 times 2x is minus 8x. Negative 4 times minus 3 makes plus 12. And that's the whole new numerator. The denominator is still those same two factors. And we do not have to multiply these back together. At least that's some good news. And now let's combine terms. I've got x squared here. 5x minus 8x is negative 3x. And 6 plus 12 is 18. But of course, you know, if I could factor this top and get an x plus 3, we would do it. If I had a minus 18 here, the top would factor. But we don't have that, so we're not going to be able to factor this top. And that means that there won't be any reducing. But we just need to remember that these two numbers cannot be part of the domain. And that's the end of that one. Now let's get one more together. Okay, we're going to be subtracting x over x squared minus 10x plus 25 minus x minus 4 over 2x minus 10. So remember, if we have to have common denominators, then we need to look at the factors of these denominators before we do anything else. So if I factor the first denominator, I get x minus 5 times x minus 5. And if I factor the second denominator, I get 2 times x minus 5. So now remember how we build a common denominator. Write down the factors of the first denominator. Now look at the second denominator. I don't have a 2, so I'll need to put down a 2, and I put mine in the front just because I'm more comfortable with the constant being in the front. And then I look at the x minus 5 and I say, oh, but I've already got one of those, so I don't need another one. Now recopying my existing problem, my first denominator only needs a 2, so I'm going to put a 2 in the bottom and in the top. My second denominator needs an x minus 5, see? So I'm going to put that in the bottom and in the top. Now I need to combine this 2x with all of this. So I'm going to have to multiply x minus 4 times x minus 5 together. Let's go ahead and figure out what the denominator cannot be. Remember, we disregard constants. So I'm not going to consider this 2, but I just know that x minus 5 can't be 0, so x can't be 5. And the 2, because it does not contain a variable, does not contribute anything to the domain. Okay, now, multiplying x minus 4 times x minus 5 and distributing, well, in a minute I'm going to be distributing this minus, but right now the minus is just sitting right here in front, and I'm going to put my trinomial in parentheses like this. So, first times first is x squared, outer times outer, and inner times inner together make minus 9x, and last times last makes plus 20. Denominator's still the same. Now let's distribute our negative. So we'll have 2x minus x squared plus 9x minus 20. Denominator's still the same. Let's combine our like terms in the top. I get minus x squared plus 11x minus 20. Because all I did here was 2x plus 9x is 11x. Denominator stays the same. Now if we could factor that top, we would do it. That top will not factor. So this one's finished. I just need to list that x cannot equal 5. So we'll do that here. X cannot equal 5.